Today we're going to talk about parametric equation applications. Kevin is skateboarding when he hits a ramp to make a jump. The ramp has an angle of 30 degrees and Kevin hits the ramp at a rate of 36 feet per second. We want to find the horizontal and vertical motion without the effects of gravity. Suppose Kevin was skateboarding in space and is not affected by gravity. How far will Kevin go up after 1 second? How far will he have risen after t seconds? So thinking about our picture over here, we have our ramp, which is at a 30-degree angle, and we're moving at 36 feet per second. So that would be like the magnitude of the vector. We're trying to figure out our y distance. So y, of course, from the angle is the opposite, and we have 36 feet per second, which is a hypotenuse, which tells us we're using our sine equation. So we have the sine of 30 degrees equals y over 36. And to solve for y, we multiply both sides by 36. So 36 times the sine of 30 degrees. And from our unit circle, we know the sine of 30 degrees is 1/2. So y equals 36 times 1/2 gives us 18 feet. So that means we've gone 18 feet after 1 second. So if we want to figure out after t seconds, we just need to multiply that by t. So that's 18 feet after 1 second. So then after t seconds, y equals 18 times t. How far will Kevin travel in the horizontal direction after t seconds? So if we want to figure out the horizontal distance, that would be here. So that's the adjacent, and we have the hypotenuse, which is cosine. So the cosine of 30 degrees equals the adjacent over hypotenuse. So this would be x equals 36 times the cosine of 30 degrees. And it says after t seconds, so we would just be multiplying this by t. And then we can simplify that because we know that the cosine of 30 is root 3 over 2. So 36 times root 3 over 2 is just 18 root 3 times t. Since Kevin cannot skateboard in space, we now will add in the influence of gravity. Gravity will cause an object to fall in the rate of -16 t squared feet per second. Adding the influence of gravity, how far will Kevin go up after 1 second? So since we're talking about gravity, which is going to affect your height or your vertical distance, we're going to be using our y equals equation to add this. So we have y equals -16 t squared. Now we're adding that to our initial equation, which was the 18 times time. And so if we want to figure out with this how far Kevin will go after 1 second, we're plugging 1 in for t and solving. So -16 times 1 squared plus 18 times 1 gives us 2 feet. So after 1 second, we've gone up 2 feet. And then it says, suppose the ramp has a height of 3 feet. What is the vertical component of Kevin's motion? So now if we're adding 3 feet, think about your transformations of your functions. When you're moving something up or down, you're just adding it to your equation. So the new vertical component would be y equals -16 t squared plus 18 times time plus 3. So that gives us our vertical component. So then E says, how long will Kevin remain in the air? So how long Kevin remains in the air means that we are trying to figure out when he's going to be hitting the ground. So we need the time that Kevin hits the ground. So if we know that we're hitting the ground, we know the ground has a height of 0 feet. And we're going to use that fact that we know that's 0 in order to help us solve for the time. So since we're talking about the vertical distance, we use the y equals equation. So we know we're using y equals -16 t squared plus 18 t plus 3. And we're substituting 0 in for y. and going to solve for the time. So in order to solve this equation, it's a quadratic equation. If we can factor, we can factor. If we can't factor, we want to use the quadratic formula. So we're going to use the quadratic formula. Our A is -16, our B is 18, and our C is 3. So remember, for the quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac all over 2 times a. So in our equation, we have, instead of x equals, we're using t as our x. So t is equal to -18 plus or minus the square root of 18 squared minus 4 times -16 times 3 over 2 times -16. And we just need to simplify this. We have -18 plus or minus the square root of, when you do 18 squared minus 4 times -16 times 3, you get 516 over 2 times -16 is -32. And we have two different equations that we're solving. So we have -18 plus root 516 over -32 and -18 minus root 516 over -32. And the next step, of course, is just to plug this into your calculator to solve for your times. So up here we get -0.1474 seconds, and we get 1.2724 seconds. Now we can't use a negative time, so therefore that means we're going to be using the 1.2724 seconds is the time it takes to hit the ground, or how long Kevin's going to be in the air. So Kevin remains in the air for 1.2724 seconds. So the next question says, how far will Kevin travel horizontally? So for F, if we want to figure out how far he's actually traveled when he hits the ground, then of course we're going to be using the time he's in the air for. So we want the horizontal movement. Remember, this one was the vertical. So for the horizontal movement, we know we're using the time as 1.2724 seconds. So we're plugging that in for time into the x. So x is equal to 18 root 3 times 1.2724. Remember, that equation was from our answer from B above. So when we plug this in, we get 39.6695 feet. So that is how far we have traveled for this problem. Of course, it just means we're traveling very fast on our skateboard. So another question that was not asked, but what if we wanted to find the maximum height, or when will we reach the maximum height? So I'm going to put another question here. So when will we reach the maximum height? So if we want to find the maximum height of a quadratic equation, we're trying to find where the maximum is, or where the vertex is. Remember, this is where your vertex is. And so we recall, if we have y equals ax squared plus bx plus c, the standard form of a quadratic equation, we can find the vertex x coordinate by this equation. X equals -b over 2 times a. And if we wanted to find the y coordinate, we would just plug that back into the equation and solve. So for our purposes, if we want to find when we're going to be at the maximum height, of course, since we're talking about the vertical distance, we're going to use our y equals equation. So we have y equals -16t squared, what was it, plus 18t plus 3. So we know, again, our A is -16 and our B is 18 and C is 3, but we don't need the C to find the x coordinate of our vertex, we're just using negative b over 2 times a. So negative 18 over 2 times negative 16. If we were to plug that into our calculator, we get negative 18 divided by negative 32, which gives us 0.5625 seconds. So that means at 0.5625 seconds, we've reached our maximum height. So if we want to actually find the maximum height, we would plug that into our y equals for t and solve. So the actual maximum height would be y equals negative 16 times 0.526 or 5625 squared plus 18 times 0.5625 plus 3. So then when we just plug that in, we get negative 16 times 0.5625 squared plus 18 times 0.5625 plus 3. So that gives us a maximum height of 8.0625 feet. So that means that our vertex would be, for this quadratic, would be 0.5625, and 8.0625 feet is the maximum height. And this is the time. So if we wanted to figure out the horizontal distance, we would then plug the time into the x equation. So if I plug that into the x equation, which we had right here, so we would get 18 times the square root of 3 times that 0.5625 gives us a horizontal distance of 17.537 feet. So we know at that time we've traveled horizontally 17.537 feet and vertically 8.0625 feet. So let's look at the next part. So projectile motion, an object that is launched with an initial position of x sub 0, y sub 0, and an initial velocity of v sub 0 and an angle of theta will travel along a path defined by the parametric equations below. And notice these are similar to the equations that we used above. We just didn't actually write the formula. And again, we're going to be using feet per second, since where x and y are measured in feet per second because of that negative 16t squared, which is accounting for gravity. We could also do meters per second, but we're going to leave it with feet per second for most of our problems. So for this example here, it says a ball is kicked from the top of a 20-foot hill with an initial velocity of 50 feet per second and an angle of 42 degrees. We'll have the parametric equation. So your x would be the magnitude, which is the 50 feet per second, times the cosine of the angle 42 degrees times time. And then we didn't have an initial horizontal distance right or left, so we don't have to add anything there. And then for y, we get negative 16t squared, that's the gravity, plus the magnitude times the sine of the angle times time. And it says that we're on a 20-foot hill, so that's why we have the plus 20 there. So that's how we come up with these equations. And I'm not going to make you guys memorize these. I think for most of them, I just give you the equation. So for question 1094, it says use the following to help you answer the questions. And so the first part we're going to be using, it says convert yards into feet is 3 feet equals 1 yard. So let's go ahead and read through the problem, then we'll read the rest of that. Olivia is in a championship golf match, and she needs to hit a golf ball over a tree to get onto the green for a chance to win the match. She is 100 yards from the front of the green. The tree is 45 feet high and is 30 yards away from her position. She chooses an 8-iron, which has a loft angle of 38 degrees to attempt the shot. She strikes the ball from the ground with a force that results in an initial velocity of 102 feet per second. Find the parametric equation that will model the flight of the ball. So let's go ahead and actually draw a picture of this first, because it kind of will help us visualize what we're trying to do here. So here's Olivia, and she's golfing. And 30 yards from her, there's this tree that is 45 feet tall. And that's, again, 30 yards from her. Now, since our gravity is using feet per second, we're going to want to change this 30 into yards into feet. So we know that 3 feet equals 1 yard. So 30 yards times 3 feet is 1 yard, which gives us 30 times 3, so 90 feet. So she's 90 feet from the tree. And so we're hitting the ball. We want to see, are we going to clear the tree? And we know that we hit the ball with a velocity of 102 feet per second with a loft angle of 38 degrees. So for our first part, we're writing the equation. So our x equations for the horizontal distance. So remember, for the horizontal distance, we're assuming that we're not on top of a platform and haven't moved right or left at all. So we're assuming we're using the origin. So this would be at 0, 0. So then our horizontal distance is the magnitude times the cosine of the angle times time. And notice that time is not inside the cosine, so you have to make sure to close that parenthesis around the cosine of 38 degrees. The time is not inside the cosine, just keep that in mind. And then we want our vertical distance, which is the gravity, so negative 16t squared. So negative 16t squared is the feet per second with the gravity, plus the magnitude times the sine of the angle times time. And again, we're not starting on a platform, so we wouldn't have to add anything here, just be plus 0, which doesn't change our equations. So these are the parametric equations that model the height of the ball. And then it says, or the flight of the ball, I should say. And then it says, will Olivia clear the tree that is in front of her? If yes, by how much? So the next part of this we want to figure out is if we're going to clear that tree. So in order to figure out if we're going to clear the tree, we need to figure out when we are going to have our ball at the tree, because we know that our horizontal distance from the tree equals 90 feet. And so because we know that, we're going to use our horizontal equation to solve for time. So we get 90 is equal to 102 times the cosine of 38 degrees times time. So we're just solving for t. Since this is all multiply, we just divide it out. And when you're using your calculator, make sure you're in degree mode. So I already know my calculator is in degree mode, but always a good idea to double check and look at your mode. So 90 divided by the cosine, or 102, use parentheses, 102 times the cosine of 38 gives me a time of 1.1197 seconds. So that means that it takes me 1.1197 seconds to horizontally go the distance of 90 feet. So now that I know the time, then I can figure out what my actual height is above the ground using my y equals equation, because that's my vertical distance. So the vertical distance would then be y is equal to negative 16 times 1.1197 squared plus 102 times the sine of 38 degrees times the 1.1197. And we're just going to plug that into our calculator to find our height. So negative 16 times 1.1197 quantity squared plus 102 times the sine of 38 close those parentheses, times 1.1197 gives us a y value of 50.2547 feet. So if the tree is 45 feet tall, then we have obviously cleared the tree because we're hitting the ball and it's going 50.25 feet vertically. So it's asking us if we cleared the tree, which we did, and by how much. So then for this, yes, Olivia will clear the tree by 50.2547 minus 45, so by 5.2547 feet. So if we look at our picture here, that means that this point right here, our x coordinate was 1 point, or actually I should say the x coordinate is not 1, it's the horizontal, or the horizontal distance, which was the 90 feet. And the vertical distance would be 50.2547 feet. And the time is 1.1197 seconds. So it takes that long to go horizontally 90 feet and up vertically 50. And this distance that we've cleared it was 5.2547 feet. So we've definitely cleared the tree. So then the next part of the question says, the green has a depth of 60 feet from the trajectory of Olivia's ball. The pin is at the center of the green. Assuming Olivia hits the ball in the direct line with the pin, how far will her ball land? And there was a note up here that says, for C, the problem says the green has a depth of 60 feet from the trajectory of Olivia's ball. This is meaning that we want to find how far her ball is from the pin, which is the hole. She's 100 yards from the front of the green plus 60 feet to the pin. So she is 100 yards, let's say, from the green. So we don't know, we'll call this the green right here. And that is from the green to the pin, which is the hole, is 60 feet. So we want to figure out how far from the pin will her ball land. So we're figuring out this distance from here to the pin, which is the hole. So we need to first figure out where she's going to land. So in order to figure out where she's going to land, we need to figure out think about a couple different things. So when we're hitting the ground, when we're landing, we know that that gives us a height of 0. So we're going to have to use that to help us solve. So the ball hits the ground. At a height of 0 feet. So if we're talking about a height of 0 feet, that's a vertical distance. Which means we use our y equals equation. So we have y equals negative 16t squared plus 102 times the sine of 38 degrees times time. So we're plugging into our y equals 0. And we can solve by either using the quadratic formula. So our a would be negative 16. B would be equal to 102 times the sine of 38 degrees. Or if you wanted the decimal for that, you could use that, which would probably be easier. So 102 times the sine of 38 gives us 62.7975. And our C value, if there's nothing being added, of course, is 0. So you can use that and use a quadratic formula, or if you can factor, you can factor. Since I don't have a C value here, it's faster to factor, so I'm going to go ahead and do that. So we get 0 equals, the only thing I can factor out of these two is t, and that would give us negative 16t plus 102 times the sine of 38 degrees. And so I have 0 equals t, and 0 equals negative 16t squared plus 102 times the sine of 38 degrees. So if I solve, then I have to just subtract the 102 sine 38 to the other side. And to solve for t, I'm just going to divide by negative 16. It's not squared, sorry. I don't know why I put the square there. So just negative 16t. So then when I plug this into my calculator, I have 102 sine 38, which I already did, and it's negative. So it's the same answer with the negative in front. Let's do negative. And then divide that by negative 16. And so that gives me the time is 3.9248 seconds. So that tells me that it takes me 3.9248 seconds for the ball to hit the ground. So that's how long we are in the air. And again, we're trying to figure out, it says, how far from the pin will the ball land? So if we know that's how long we're in the air, then we then need to take the time and plug it into our horizontal distance. So we're going to take this time and plug it into horizontal distance. So the horizontal distance the ball has traveled would be x of 3.9248. So I'm plugging that into my x equals equation. So that would be 102 times the cosine of 38 degrees times the time. So 102 times the cosine of 38 times 3.9248 gives us 315.4640 feet. So that means the ball is 315.4640 feet from the starting point. And so now we need to figure out how far we are from the pin. So remember, we need to do some conversions here, because if you look back at our picture, we said that we were 100 yards from the green. So 100 times 3 would give us 300 feet. So the distance from where we started to the pinhole is 360 feet. So the distance from start so the distance from your starting point to the pin, which is the hole, is 300 plus 60, or 360 feet. So if we want to, again, figure out how far from the pin will her ball land, we're just going to subtract. So now we have to take 360 minus 315.4640, which gives us 44. So the time will be, or the distance will be 44.536 feet. So Olivia's ball is 44.536 feet from the pin. And that is it for our notes for